All right, in this lesson, we're talking about direct variation. And direct variation is just simply a linear relationship between two variables that can be written in the form of y equals k times x, right here, or k is equal to y divided by x, where k is not equal to 0. And that number k is called the constant of variation, and it is the same all throughout that particular the particular problem or the particular relationship we're talking about. Okay, so and then a lot of times we'll use k equals y divided by x to figure out what that constant of variation is. All right, so it says, tell whether the equation y plus 8 equals x is a direct variation. Well, remember, it's the direct variation says y is equal to a number k times x, all right? Well, in this case, we have y plus 8 is equal to x, and then we subtract 8 from both sides to get the y by itself, and subtract 8 over here, and we end up with y is equal to x minus 8. All right, and you notice in the direct variation equation, there's no adding or subtracting, so that means that this is not a direct variation. Okay, because of that minus sign. All right. Next one. Tell whether the equation 3y is equal to 2x is a direct variation. Okay, remember we were looking for y is equal to a number times x, or k times x. So we're going to say 3y is equal to 2x. Okay, to get the y by itself, we're going to divide both sides by 3. Divide both sides by 3. And we end up with y is equal to 2/3 x. And so, yes, this does look like it's y is equal to a number. In this case, the number is 2/3 times x. And so the constant of variation, COV, is equal to 2/3. Okay? All right, so this says, does the table show a direct variation? If it does, what is the constant of variation? So basically, in this case, we're going to divide the two numbers and divide the two categories and see if the ratio is the same for all of them. Okay, so, and it doesn't matter if we take the top divided by the bottom or the bottom divided by the top, but I'm going to do the bottom divided by the top. So I'm going to do 2.54 divided by 1 is equal to 2.54. Okay, that's my constant of variation right there. For the first one is 2.54. I'm going to say 5.08 divided by 2. Okay, get the calculator, and I say 5.08 divided by 2. Whoops, I said times 2. No. 5.08 divided by 2 is 2.54. So there again, this is 2.54. This is 2.54. So let's take 12.7 divided by 5. Divided by 5. Okay. And so when I do that, I'm doing 12.70 divided by 5 is 2.54. So we notice that when I divide, it's the same variation, or the same ratio is exactly the same. So the constant, the COV, is 2.54, and it is a it is a direct variation. All right. Here, let's try this. Okay. So we're going to say 5 divided by 2. All right. 5 divided by 2 is 2.5. All right. So that's 2.5 right here. We're going to do 10 divided by 3. Well, we're going to do it on a calculator, but I think it's pretty easy to see that that's not going to be 2.5. 10 divided by 3 is 3.3. That keeps repeating. Okay, and we don't even have to look at this last one, because we can already tell that the variation, the direct variation, is not the same. So this would be a no. All right. All right. So in a direct variation, the slope k represents a constant rate of change. So the direct variation, the constant of variation, is the same thing as a constant rate of change. In our last lesson, we talked about the constant rate of change being shown on a graph as a straight line. All right. And so we see here in this one here, it says, does the graph represent a direct variation? Well, yes, it does, because it's a straight line. It says, if so, identify the constant of variation. Well, the constant variation is just simply the slope. And remember, to find slope, we pick 2 points and do the rise over run. So this looks like 1 point right here. And let's see here. If we look, another point would be like right here. Okay, it looks like it's there. Right there is a point. Okay, so if we go from here to here, our rise. So we're going to do rise over run. Okay, so our rise would be -1, and our run is 1, 2. So 2. So the slope is -1/2, or k is equal to -1/2. All right. Number 7. I mean, not number 7. The next one, page 7. It says, does this graph represent a direct variation? Identify the constant of variation. Well, it's a straight line. It's a straight line. So yes, it is a direct variation. So this would be a yes. And so we just look at the slope. Well, let's see here. Here's a line. Here's a point. And we'll say down here's a point. Okay? Because that's pretty close. So when we count this, 1, 2, 3, 4. So our rise, remember we do rise over run. So our rise is -4 because we went down. And so now we do our run. 1, 2, 3, 4, 5. Okay? Just count again. 1, 2, 3, 4, 5. So our slope is -4/5. So our constant of variation, that's the constant of variation, is our slope, is -4/5, or -4 to 5. Okay, -4 over 5. So that is, I think, yeah, that is it for this particular lesson. Make sure that you write down all the notes. Make sure you ask me questions if you have any questions, and we'll talk to y'all later on.